I was just remembering earlier, I went to a presentation many years ago, and there was a guest speaker from BMW, and he was a big marketing director of BMW. He was late, but he kept in touch by phone, and everybody took the coffee break early, and they went out. And then they came back in, because they said, he's arriving, he's arriving. And then everybody got in their seats, quite a big audience, and he stomped with a couple of minders right to the front, got to the podium, and he said, today I'm going to be talking about whatever he was going to be talking about. If that's not what you're expecting to hear, please leave. That's what I'm expecting to talk about. I'm relating the automotive industry with... Oh, by the way, he actually said I'm going to be talking for 22 minutes on the subject of, if that's not what you're expecting to hear, please leave. And I timed it, because I'm that sort of character, and it was 22 minutes. Amazing. This one's got to be about 2 minutes, actually, because we're behind schedule. I'm relating the automotive industry to the industrial inkjet printer industry. We both build stuff out of thousands of components, but my premise is that perhaps if we built VW Golfs, they'd cost $250,000. And if VW built industrial printers, they might tend towards the 25,000. Now, of course, that's ridiculous. But they are more optimized than we are, because they're more mature. So maybe we can make our products more sellable by building them in a different way. Vertical integration is something I hear often in Inkjet. People want to do their own this and do their own that, and they think that capability distinguishes them from another. But what it results in is everybody reinventing wheels. So there is a better way. And specialist things cost a lot to develop, so the only way to actually spread that cost is to get volume, and volume comes from those things being in every application, the many applications that industrial inkjet covers. Now, one of the things, if you develop your own drive electronics, for example, you tend to develop for a narrow range of print heads, or maybe even one range. And then if you want to diversify into a different capability, that's difficult, because you have to start from zero and do it all again. So many OEMs, even the biggest, they actually focus on print heads, and they try and push the boundaries one side or another, performance or image quality or whatever, but they try and stick with their... And some of the print heads lend themselves to that better than others. But it's constraining, and there is no one print head that does everything. So having the flexibility to be able to choose the right print head for the job is a major advantage. To enable each variation of each print head from each of the print head manufacturers is a big job, and it takes a lot of engineering. Now, either you could have all of the, something like 700 OEMs developing their own things, doing everything in parallel, duplicating. It could be that certain things it's better to actually just get off-the-shelf solutions and then build it together like a VW is built of components that exist for other cars. We know that from our perspective, we spend a lot of money on developing for each of the print heads and the print heads that are coming over the next few years. So it's a big burden to actually try and do that as a specialist in that area. It's an even bigger burden if you're an OEM and you have to develop everything else as well. It's not just whether it's possible or what should be done, it's actually how long it takes. And I sort of reviewed at the bottom on the right there, that's a print head. From all the data that could be assembled, that is the path of a print head. That print head, and I won't say which one it is, it's still losing money. It'll never pay back the investment in what it costs to bring it to market. It's a fantastic device, but it's that break-even point. So what you actually need is this sort of thing. It's the green line, not the red line. The longer it takes to get to market and the less steep the ramp-up is, the more difficult it is to reach that break-even point in a really reasonable time. So time to market is not just time to market for the print head, it's time to market for the printer, and then it's adoption of the printer. So this is all rolled up into the success stories of the things that we build. The data path is often a constraining factor. So if you've got the data path to be developed when the printhead is ready, then that adds something on, some months, let's say, in some cases more. You can actually electronically simulate a printhead at the early stages of its development, and you can, that's what GIS does, so that you can develop in parallel. I'm not saying that always happens, but it can. And it should. We're developing for 12 printheads this year. That's a lot of resource piled into a program of delivery, which will enable OEMs to use a selection of different printheads, some of which aren't announced yet, but will be announced through the year, some of which are known but not yet ready, but they're all coming, and that gives extra capability. Then we come to this point, and there's somebody in the audience here, he knows who he is, asked this question at a previous conference. Why don't printhead producers make better printheads so that we don't need all the clever software? And that's a perfectly reasonable question. However, the efforts from all those years I've spent in printheads, I know that it's very difficult to improve. It's been improved over the last 10 years, tremendously. So drop mass uniformity, velocity uniformity, row to row, so you get image density much better than ever before. None of those smiley profiles where you get end drop-off. It's all improved, but you can only improve to some degree. And then the needs of imaging mean that you need even better. That's where software comes in. It's a specialism that inevitably has to be outsourced because nobody could do that to the fullest extent. Even the biggest will struggle. So that's maybe one of the things that we should do in a Volkswagen way rather than a vertically integrated way. And not even people like GIS can do it. And there are some industry standards, FIRE, ESCO, and so on. Users are used to those things, and they work in particular ways, they're familiar with it, and it does the job that's needed in the application. So linking our part to those parts actually makes sense, and it's connected, it's collaboration, it's efficient. So looking at the products that we produce, we've got old Golf, new Golf, which is small, expensive, big, and much cheaper. You see the passage of the cars as a proportion of disposable income over time. It's come down, 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 down. That's the way things go. It's got more in it. It's got toys and gadgets and navigation systems and fancy wheels and all sorts of things, and it goes faster and it uses less fuel. It's actually a much better product over time, and it's become more affordable. Looking at printers, there is a success story here with ceramics, and I think it's been mentioned. There are some people in the room who've played a part in this themselves. The blue is the line of price. It's come down, but simultaneously, the capability has gone up. Twice as many color bars to get imaging better, to improve the imaging and the capabilities of the systems. Wider, so you can do porcelain instead of the smaller tiles. The average was 70 centimeters, and it's gone up to above 1.2, and in some cases it's 1.8 for ceramics printers. So many more printheads in. And you can look at the green track. Printhead price has come down to enable that capability to go into it. So these are some comments from the ceramic industry. I won't go through them, but printer sizes have changed a lot over the years, just like cars. That's just something that came out from somebody in the industry. Cheaper due to competition. They used to cost about 350,000. They've come down from 500,000 to 350,000, and they're not comparable because they do so much more. So that's paralleled with the Golf story, if you like, but it's not the true of all of the things that we produce in the industrial inkjet market. Looking at the elements of a printer cost there, and this is something I did, I think it was during COVID, early part of COVID. I was, from a printhead perspective, you can see down at the bottom there, reduce the cost of data path and drive, and make it easier to access. That's what I was talking about when I was from the printhead side of things. It looks very bleak there, doesn't it? In COVID, it was like that. It was dull. We weren't in this then. So it was quite a reminder. But I was looking at the proportion of the components in a printer, which their value was, and which bits. Those are the bits that you should focus on. Now, if you look at the blue and green, the light blue and green, they're the software and drive electronics, which is the GIS part. And the yellow, in those selection of printers, and I haven't specified what they are, but they're all real printers. There's some that spend a lot on print heads, some that spend quite a lot on drive electronics and software, some that spend less. And the other cost, there's different business models. If it's low volume, then you have a contribution to the overhead. But squeezing some of those costs and doing it in a more optimal way might actually deliver more competitive products, end products, that appeal to end users so that there can be a greater adoption. And as a component supplier to the OEMs, we should be looking at the adoption rates and which printers are going to sell in the markets. So optimizing is outsourcing specialist components where possible. So if you want to build a printer, you don't manufacture your own print heads generally. But there are other things in the chain where maybe outsourcing makes more sense now than ever before. So there are positives and negatives. We're a bit time constrained here, so I'm going to skim through. It's often said that if you make your own, you control your own design and build, but then you lengthen your time to market and you have to carry all of that overhead. If you buy, you can have access to the widest portfolio of printing capability, and you're sharing the overhead that's gone, the investment that's gone into all that development. You're sharing that over the volume with your competitors, yes, but with other industries. So you might get a better deal. The components can be expensive if they're bought, but that's just the nature of small, less mature component vendors like GIS. So the vendors have to step up, as well as the OEMs sort of shifting their views. But I think outsourcing makes sense. Now, complexity. If you want that, in the inkjet industry, the component suppliers offer that. But that doesn't work in there, because it doesn't make it useful. And this is on a theme of, we tend to make things more complicated. And I speak from GIS. I've always known GIS as somebody who has complexity on the outside. Making that simpler and more easy to use is like translation from techie to user. So I think sometimes you can take that and you can have all that behind the scenes in the computing that goes on behind it, but really the user actually wants to see only what they want to see. So I think tier one vendors, if we are automotive tier one, we'll be making complex things look simple, not the other way around. Then there's how we sell our products. I've seen so many situations at exhibitions and so on where you actually get customers looking inside, and you open the bonnet and look at and show how complex it is, and how clever are we? And we talk about how unreliable, how volatile our systems are, when in fact the car dealer actually just makes it look sexy and simple. GIS comes from techie. We've got some really techie people who are very interesting, but you have to kind of figure out how to use it. Now, we've got lots of knowledge, so we should have a low ego. But if you've got a big ego, then it doesn't work. So the techies have to reduce the ego, I think, with more knowledge and sharing that knowledge. There is a topic that's, everybody talks about AI. We've got a part of the group that's in DeepCube that's in AI, and applying that to usefully is also something that we should explore, but I'm not talking about that today. So, in summary, takeaways. It doesn't make sense to reinvent wheels, of course. If there is a wheel, then why not use it? Deliberately, not accidentally or in an unqualified way, differentiate by design, use what's available to make the overall solution differentiable, because it's more useful, easier, faster to market. Specialist things need a lot of resource, so why better do it in one place or two places or 5 places as competitors in that specialism than for each of the hundreds of OEMs to do it themselves. So outsource where it makes sense. Vendors need to make it possible to outsource as well, so that's the responsibility of the vendors. So it's no good if you just say, well, just buy really expensive, complicated things, because they're there. They have to be made suitable. That's what Tier 1 automotive does. And just using this type of tier 1 approach should mean a more efficient way of building inkjet printers. That's my premise. There are some limits on what hardware can do, inkjet print heads, and the software element shouldn't be underestimated to give reliable results and high uptime. So it is necessary. And that's all I'd like to, I mean, I've skimmed through because I think we're pressed for time. The general theme is we could do it differently and maybe the end result would be more sellable. So thank you for listening.
Thank you very much. Excellent.